We've got these incredibly powerful telescopes right here on Earth, all pointed at our nearest star. But for decades, there's been one huge problem standing in the way of a perfectly clear picture: our own atmosphere. Well, it turns out a new AI method called NeuralBD is changing everything, giving us some of the most stunning, crystal clear views of the sun ever taken from the ground.
And when I say crystal clear, I mean this. Just take a second and look at it. This is the goal. This is what we're aiming for. You can see the texture of the solar surface, that churning plasma, the whole intricate dance of light and shadow in just unbelievable detail. It's absolutely spectacular.
That's a fair question, right? I mean, if our telescopes are capable of seeing that, what's stopping them from getting that shot every single time? What's the big hurdle we're trying to get over?
Well, because this is what that same telescope actually recorded. A blurry, distorted, shimmering mess. See, the problem isn't the camera or the lens, it's the chaotic, turbulent air it has to peer through just to see the sun. The difference between the two is, well, it's just staggering.
So, let's dig into this challenge. What exactly is happening in the sky between the sun and our telescopes that causes this much trouble?
The scientific name for it is atmospheric seeing, but honestly, the best way to get it is to imagine you're at the bottom of a swimming pool, looking up at the sun. The water makes everything shimmer and blur, right? Well, Earth's atmosphere does the exact same thing to sunlight, scrambling all that precious information before it even gets to our telescope.
Now, scientists have been battling this exact problem for years. It's not like they've just been putting up with blurry images. So let's take a quick look at the clever methods they were using before this new AI showed up. So, techniques with fancy names like speckle reconstruction have been the workhorses for a long time, but they have some big limitations. Think of it like trying to fix a blurry photo without knowing how it got blurred. Was the camera shaking? Was it out of focus? These older methods had to guess. They had to make assumptions about what the atmosphere was doing, which limited how big of an area they could fix, and sometimes even introduced new mistakes into the final picture. And that brings us to the breakthrough, a totally new way of looking at the problem, all built on a special kind of neural network. It's called NeuralBD.
Okay, now this is where things get really, really cool. Instead of trying to unblur the image directly, NeuralBD actually works backwards. The AI makes a guess of what the perfect, clean image should look like. At the exact same time, it makes a guess of the specific atmospheric blur that messed it up. Then it applies its fake blur to its perfect image guess to create a prediction. It compares that prediction to what the telescope really saw, and if they don't match, it tweaks both of its guesses, the image and the blur, over and over and over again until its fake blurry picture is a perfect match for the real one.
So here's the real game changer. The old methods had to assume what the blur looked like based on general models. But NeuralBD, it learns the exact unique blur for that specific moment directly from the data itself. There are no assumptions. It solves for both the true image and the distortion at the exact same time. It's a whole new approach.
Now that all sounds great in theory, but the real question is, does it actually work any better? Let's look at the head-to-head results.
The numbers on simulated data are, well, it's not even a fair fight. You don't need to be a data scientist to see what's happening here. On the first metric, lower is better, and NeuralBD's score is tiny. On the other two, higher is better, and it's just in a completely different league. This isn't a small improvement. It's a massive leap forward. And this is what those numbers actually look like. On the left, that's the blurry input from the simulation. On the right, that's the original perfect image they were trying to recover. And in the middle, that's what NeuralBD did. It's almost indistinguishable from the original. It pulled an incredible amount of detail out of that blur.
Okay, so simulations are one thing, but what about real-world data? This is from the GREGOR telescope. On the left, that's an original blurry frame. On the right, the NeuralBD version. I mean, just look at the fine structures it recovers, those sharp edges around the bubbles of plasma. The AI is pulling out details that were just lost in the noise before.
And it doesn't just work on older data. This is from one of the most powerful solar telescopes on the planet, the DKIST. Now, this telescope already has incredible technology to fight atmospheric blur. But even so, look what happens. NeuralBD takes these already world-class images and just cranks the sharpness dial up to 11. And here's something extra fascinating. Remember how the AI has to learn the exact blur to solve the puzzle? Well, it can actually show us what it learned. Each one of these squares is like a blur fingerprint.
the specific pattern of atmospheric distortion from that exact moment. For the first time, we can actually see a direct measurement of the turbulence the AI just erased.
So why does all this matter? I mean, having prettier pictures of the sun is nice for sure, but the scientific implications here are the real story. This technology could seriously change what's possible in solar science.
So what does this really mean for us? It means we can finally see the tiny, intricate magnetic field structures that are the engines behind massive solar flares and space weather, the kind of events that can directly impact us here on Earth. It means our newest generation of super telescopes can finally be used to their absolute full potential. We're getting a more accurate, less filtered view of our star's chaotic surface than has ever been possible from the ground.
This technique essentially just wiped the condensation off our window to the sun. So it really makes you wonder, with the blur of our atmosphere finally removed, what hidden dynamics and fundamental secrets of our star will we finally be able to see clearly for the very first time?